Hello everybody! Today we're starting our next section, which is going to be analyzing angle measures that are formed by chords, secants, and tangents. So if you do not understand what those components are, I strongly suggest going back to previous note sections and looking at those terms so you fully understand those as we go through these calculations. Heads up, if you hear some noise in the background, that's my big potato dog Reese. Alright. As far as angles within a circle, we've mainly looked at central angles and we've looked at inscribed angles, but those are not the only angles that can be composed within a circle. And depending on the certain type, there's going to be different calculations. So the first type we're going to be looking at is interior intersections that create angle measures. If you have two secants or chords that intersect inside a circle, then the measure of the angle formed is equal to half of the sum of the measures of intersected arcs, okay? If, in this example, I'm wanting to solve for angle measure 1, let me change colors here, I'm going to calculate 1/2 times arc AD plus arc BC. So it's kind of like, the way I like to think of it is those vertical arcs. Think of it, remember when we went back over vertical angles? It's those angles that are right across from each other. Here, we kind of have vertical arcs. So whatever arcs that align through that angle, those will be the arcs that you add up. So let's say, for example, if I was looking at angle 2, the measure of angle 2 is going to be equal to 1/2 of arc AB plus arc CD. And those arcs and angles are all in alignment. So let's look at some calculations. Here, in example 1, I'm wanting to solve for the measure of AED. In order to find AED, I'm going to set angle AED equal to 1/2 times arc AD, so 45, plus 109, because they're right across and it's all in alignment. All right, 45 plus 109 is equal to 154. 154 divided by 2 is equal to 77 degrees. So my angle measure for AED is 77 degrees. Okay, let's do another example. Let's say we're not given the arc measures and we're given our angle. Here I'm wanting to find the arc measure of CDE. Well, I know 128, that angle measure, is going to be equal to 1/2 of arc CDE plus 73, that arc that's right across from it. All right, throw back to algebra, and I'm going to distribute that 1/2. So it's going to be 1/2 times CDE, arc CDE, plus 1/2 times 73. So 73 divided by 2 gives me 36.5. I'm going to subtract 36.5 from each side. So 128 minus 36.5 gives me 91.5 equal to 1/2 times CDE. To get my arc measure by itself, I'm going to multiply by 2 to cancel out that fraction. Multiply by 2, so 91.5 times 2 gives me my arc measure for CDE, which is 183. All right, so and that's just one type of intersection. For all the circle intersections, if we have a secant or a tangent that intersect at the point of tangency, then the measure of each angle formed is equal to half the measure of its intercepted arc. So, for example, here, if I'm wanting to solve for angle 1 is going to be equal to 1/2 of arc AB. For angle 2 is going to be equal to 1/2 of arc ACB. So you just take that arc measure, divide by 2, or multiply by 1/2. Okay, so this one's not too shabby. Example 3, I'm going to try to find for angle DBC. It tells me that this arc measure right along here is 192. Do I know my arc measure that's right across from my angle? No, because I'm wanting to try to find angle DBC. I don't know what this arc measure is, but I can solve for that. How can I solve for that arc measure? Well, all the angles around the circle add up to equal 360. So I can take 360, subtract 192 to equal that measure. So 360 minus 192 is going to be 168 degrees. So now that I know that arc measure, I can take that arc measure, divide by 2 to equal my angle measure. Give me an answer of 84 degrees. All right, our last type of intersection is going to be exterior intersections. And these ones look super duper complicated because there's different types of secants and tangents. However, the underlying theory is very similar. So if you have a secant or a tangent that intersect on the exterior of a circle, then the measure of the angle formed is equal to half the difference of the intercepted arcs. All right, so in all of these examples, I'm wanting to solve for angle A. Okay? Despite the type, the way these equations work is angle A is going to be equal to 1/2 multiplied by the outer intercepted arc minus the intercepted arc. So if you have two secants, okay, you're going to take 1/2 times the outer arc of CE minus the inner arc of BD. If I have a secant and a tangent, I'm going to take 1/2 times arc BD, that outer intercepted arc, minus that that inside intercepted arc. And the same is consistent for two tangents. Okay, you're going to take 1/2 times the measure of that outer arc minus the measure of that inner arc. So with these problems, you necessarily don't have to identify whether it's a secant or a tangent to understand your equation. I mean, if you do understand the concept, that's excellent, but it's not fully required in order to solve the problem. So let's look at this in practice. Here, for example 4, I am wanting to solve for angle KLM. Angle KLM. Well, to solve for that angle measure is going to be equal to 1/2 times my outer arc, which is 140, minus my inner arc of 66. So 140 minus 66 gives me 74. I'm going to divide that by 2 to give me my measure for KLM, which equals 37 degrees. All right, let's look at another problem. Oh, that should be, wait, shouldn't that be example 5? Yeah, example 5. Here, I'm wanting to solve for an arc. I'm wanting to solve for arc EF. Okay, this one's a little bit different. I'm wanting to solve for arc EF. Well, let's fall back on our most basic theorem, is all of those arcs add up to equal 360. So if I can solve for this inner arc right here, arc FH, I can solve for arc EF. Okay, how do I solve for arc FH? Well, that angle, FGH, 77, is going to be equal to 1/2 times that inner angle Y. Oh, nope. Not that inner angle, that outer angle, 191, minus that inner angle Y. Whoop. Once I solve for that inner angle, I can solve for X. All right, so a little bit of distributive property. 77 is equal to 1/2 times 191. So 191 divided by 2. Oh, my calculator's malfunctioning. 95.5 minus 1/2 Y. I'm going to subtract 95.5 over to isolate my variable. So 77 minus 95.5 gives me a negative number of negative 18.5. Don't freak out yet. Okay, because that negative that 1/2 is negative. So when I divide by that negative, it will make it positive. So I'm going to multiply by -2 on both sides to get rid of that fraction. So negative 18.5 times -2 giving me my final measure of 37. So this arc right here for arc Y, or I'm sorry, arc FH, that's 77 degrees. In order to solve for arc EF, I'm going to take 191 plus 37, which gives me 228. And then I'm going to take 360 minus 228, which is 132. Let me double check my math, make sure. Yep, there we go. Woo. So arc EF is going to be equal to 132. Let's do one more example before we call it a day. Here I am wanting to solve for angle PQR. Right here. Okay? The only information is I'm given that arc PSR is 313 degrees. How am I going to solve if that's the only quantity I'm giving? Well, remember my circle properties. All of my arcs add up together to equal 360. So if I know that outer arc, I can subtract that value from 360 to get PR. So 360 minus 313 gives me 47 degrees. So that inner arc is, oh, nope. The inner arc is 47 degrees. Now that I have that value, I can solve for angle PQR, which is going to be equal to 1/2 times 313 minus 47, which is 266. I'm going to divide that by 2 to give me my angle. So angle PQR is equal to 133 degrees. And there you have it, folks. So that's all the information we're going to be covering today. Make sure you review and understand these calculations and let me know if you have any questions.